Hello everybody. In this video we will learn about section 3.6, that is rational functions. I will divide this section into almost 3 or 4 parts. So where I'll be covering, where we will be learning in part 1 about rational functions and how to find out their asymptotes and how to apply transformation on the function 1 over x to obtain different kinds of rational functions. So we have already defined rational functions, but to have a quick recall, a rational function which I will be abbreviating as RF, that is my abbreviation to write less, to avoid more writing. So a rational function is of the form P of x divided by Q of x, right? So where P of x and Q of x are polynomials. So this is how it is different from just an algebraic expression and an algebraic function, or especially why it has to be a rational function, right? So Q of x need not be 0, and P of x is a P of x and Q of x are polynomials. So that means they are combination of different monomials. So now in this we will consider a simple rational function, that is f of x is equal to 1 over x. Okay, so you know how to plot the function based on table of values, right? So you choose arbitrary x values and find out their functional values, and you know how to plot them on the coordinate plane. So there is a method wherein you have to do it like you have to take values towards 0 from the negative side, and from 0 towards the positive side. Okay, so that will lead to something called as judging the asymptotes or the limits in a higher level. So you will learn that very soon. So this kind of finding out table of values, that is considering table of values very closer to 0, but from the negative side approaching 0, and very closer to 0 from in the positive side, approaching 0. Okay, so this is very much necessary to calculate what is called as asymptotes. So let us do that. So this function is not actually defined at 0, correct? When the denominator is 0, we do not know what happens to the fraction. It is undefined. So we have to find out the values of the function when x is close to 0, whether it is closer on the negative side or the positive side. So we will calculate x f of x. So if x is closer to the negative side, you will have 0.1, negative 0.1, negative 0.01, negative 0.000, like 4 zeros and 1. So their corresponding functional values will give us for negative 0.1, 1 over negative 0.1 is 10, and 1 over negative 10, sorry, and 1 over negative 0.01 would be negative 100, and this last decimal point would give us its functional value would be negative 5, that is 10,000, negative 10,000. And this is when the x values approach 0, approaches approaches 0 from the negative side. Okay, so from negativity in or from negative infinity, it approaches 0 from the left side. Okay, so and x is equal to f of x, x and f of x. Now we will choose the same values but on the positive sides: 0.1, 0.01, 0.00001, and this would give us 10, 100 and positive 10,000, right? So what is happening here, as you're approaching x is approaching, I'm sorry, okay, x is approaching 0 negative. Okay, and what is happening to the functional values? You can see it is exponentially raising, like it is increasing a lot, because you know what happens if the denominator of a fraction takes lesser value, like it keeps taking lesser value, in the sense the functional value or the fractions value will be increasing. So if the denominator value is less, the fractional value will be bigger, and if the denominator's value is more, the fractional value is also more. So here you can see that from 10 it went to 100 and then to 10,000. So the functional value is abruptly increasing, so it is approaching negative infinity. And what happens to the positive side? It is the same even when the approach of x is to 0 plus. So it is reaching 0 plus some small value, correct? So that would give us 0.1 and 0.01 and so on, and functional values are tending towards infinity, that is positive infinity. So if we have to describe this behavior in words and in symbols, so the first table, which shows that as x approaches 0 from the left, the values of y is equal to f of x will decrease without bound. That means it goes to negative infinity. What can we write it as symbols? So f of x will tend to negative infinity as x will tend to 0 minus. So 0 minus in the sense overhead minus. This represents that x is approaching 0 from left. So y approaches infinity. And the same symbol, the same can be represented as symbolically for positive values. That is the second table that shows that x approaches 0 from right, and the values of f of x increase without bound. So there is no bound for that, means f of x will tend to infinity as x tends to 0 plus. So 0 overhead plus sign implies that the values of x are approaching 0 from right. Okay, so you can do the same thing for another function. So the next function would be absolute value of x. Okay, so absolute value of x, you know that if you take negative values, the absolute value will be what happens to the absolute value? This is not in a fraction form, where it is definitely in a fraction form, but the denominator is 1. Okay, so which shows how your absolute value becomes higher and higher, that is, it becomes larger. So if I take say x tending to okay, so suppose if I consider x tending to 0.1, so absolute value of x will be 0.1, negative 0.1, correct? And x, if it is 0.001, then absolute value will be 0.001 itself. And you can see, like, this is nowhere near to infinity. The functional values are not approaching infinity, but what it is approaching 0. As the x values approach 0, functional values also approach 0. So yeah, so if this, you can write it as f of x will tend to 0 as x tends to 0, correct? And what happens to the positive side? as x tends to 0 minus, yeah, and even on the positive side f of x will tend to 0 as x tends to 0 plus, because the functional values will be same irrespective of the x being negative or positive. So with this information we can define what is called as vertical and horizontal asymptotes. So let us denote things in the arrow notation. So symbol and meaning. So let us define this first. If x tends to a minus, it says that x tends to a minus, so x approaches a from left. Okay, so and if x tends to a plus, so it says that x approaches a from right. Okay, so and x tending to negative infinity, it implies that x inverts it, you can say it as x tends to negative infinity, and that means x decreases without bound. X decreases without bound. And if x tends to positive infinity, inverts, you write it like you say it to be x tends to positive infinity, and that implies x increases without bound. Okay, so now let me define what is a vertical asymptote. Vertical asymptote. Okay, so if you have your function f of x is equal to 1 over x, f of x is equal to 1 over x, so you have the function to be of this form. So let me use a graphing calculator. Y is equal to 1 y is equal to 1 over x. So you can see the graph now very clearly, and you can see that x is equal to 0 is the vertical asymptote here, because as x takes the value 0, or x approaches 0, what is happening to the y value? It is tending to negative or positive infinity, right? So that is the vertical asymptote. And what is the horizontal asymptote? That we looked while we were calculating the table of values. So what would be the horizontal asymptote? Horizontal asymptote would be the line y is equal to 0, because when y is 0, your x value or your x value will approach positive infinity or negative infinity. Okay, so we will come back to the graph after I define vertical asymptote. So vertical asymptote is a line. Okay, the line x is equal to a is a vertical asymptote of y is equal to f of x if y approaches plus or minus infinity as x approaches a minus or x approaches a plus. That is, x approaches a from left or x approaches a from right. So to denote things graphically, if I draw a graph, Okay, these are the two graphs. This is our x-axis and y-axis, and here, okay, I'll draw it a little better. Yeah, and okay, so you can see that what is happening to the y value as it if our a is here. So if as a is from this input value, I will mark it in green. So from this value to a, so you can see that there is a substantial raise in functional values. So the functional values are quite like increasing with a small change in x value, right? So if you approach towards a on the positive side, that would be a plus, correct? And if you approach towards the negative side, that would be a minus or from the left or right side. So you can see that f of x is, if red is f of x is tending towards infinity as x tends towards a plus, and f of x is tending towards infinity as well, because you don't have negative functional values. Oh, sorry, not here, in this diagram. Okay, so in the other diagram you have x tending towards infinity as f of x tends towards infinity as x tends towards a minus. So this is our a. So the line which says that gives us the vertical asymptote is x is equal to a. So when do you have any line that can be y-axis or parallel to y-axis? When you have x to be constant and your y values are changing, right? So that is your vertical asymptote. So vertical asymptote is that line where the functional value tends towards positive infinity or negative infinity at the constant where the x is being equal to. The second definition is our horizontal asymptote. Okay, horizontal asymptote, when do you have a line? It is again a line. When is it parallel to x-axis? When you have it to be when your y value is constant and your x value is changing, right? Or y value is 0. Okay, so the line y is equal to b is a horizontal asymptote. I write it as HA. So is a HA of f of x of y is equal to f of x if y approaches b as x approaches plus or minus infinity. So x value is increasing to infinity, plus infinity or negative infinity, but y approaches b. So applying this definition to the example that we did, that is y is equal to 1 over x. Okay, so here you saw that f of x was tending towards positive infinity and negative infinity when x takes the value when x approaches 0 from right or left, right? So therefore the vertical asymptote is x is equal to 0. And I didn't calculate the higher values of x. So let me do a higher value as x tends to positive infinity or negative infinity. So positive infinity would be when x takes these values, right? So f of x will become 1 over 10 is 0.1 and 1 over 100 is 0.001, and this would be 1,000,001. Okay, so the functional value is tending to towards 0. So y, this is the vertical asymptote, and y is equal to 0 is the horizontal asymptote. Because as x tends towards positive infinity or negative infinity, f of x will tend towards 0. Okay, so I hope you understood this. Let us do another exercise problem for better understanding. This is problem number 10 in your book. So r of x is equal to 4x plus 1 divided by x minus 2. Okay, so the question says that a rational function is given. Complete each table for the function and describe the behavior of the function near its vertical asymptote, and determine the horizontal asymptote based on table 3 and 4. Okay, there are tables given, so let me write table 1. So a table 1 has values x 1.5, 1.9, 1.99, 1.999. So you can see that x is approaching 2, correct? So let us see what happens to the functional value if you substitute the following 4 times 1.5 plus 1 is 7. Okay, so this will be 7 divided by 1.5 minus 2 would be negative 0.5. 7 divided by negative 0.5 would be 14. Sorry, negative 14. Okay, so what happens if x is 1.9 plus 1? Okay, the numerator will be 8.6 divided by 1.9 minus 2 is negative 0.1, correct? So 8.6 divided by negative 0.1 will give us negative 86. So you can see with a small change in the value of x, there is a substantial increase in the functional value. So as x tends towards, so you can calculate the rest of the values. So as x tends towards 2 from left, right? So 2 minus, then what happens to f of x? F of x is tending towards negative infinity. Okay, so let us calculate table 2 for the same function. So table 2 says that x is taking values like from right approaching to 0, 0, 1. Okay, so what happens if x is 2.5? So 4 times 2.5 plus 1 would be 11 divided by 2.5 minus 2 is 0.5. So 11 divided by 0.5 is 22. Okay, so what happens if x is 2.1? 4 times 2.1 plus 1 would give us 47.5. That is 47 divided by 5, that is 9.4. So 9.4 divided by 2.1 minus 2 would give us 0.1. So divided by 0.1 is 94. So you can see as x tends, calculate the other two values by yourself. So as x tends to 2 plus, f of x is tending towards infinity. So what is our vertical asymptote? So vertical asymptote is our line. The line x is equal to 2, correct? So with the other two table values, that is table 3, we have x to be 10, 50, that is x is tending towards positive infinity, 100 and 1000. So what happens to f of x? So f of x will be 4 times 10 plus 1 is 41 divided by 10 minus 2 is negative 8. So 41 divided by negative 8 will give us negative 5.125. Okay, so then when the value of x is 50, so 50 times 4 is 200. 200 plus 1 is 201. 201 divided by 50 minus 2 would give us 48. So 48 is 4.1875. Okay, I think I did something wrong here. It's positive 8. Yeah, the value is positive. Okay, so the value would be 4.1875. I need some more values to identify to which particular number it is going closer to. So let me find out what happens if x is 100. So 400 plus 1 is 401 divided by 100 minus 2 is 98. So it is 4.0918. Okay, so when it is 1000, so 4001, correct, divided by 998. So that would give us, yeah, 4.00901. So it is approaching 4. You cannot conclude with 5. So because there is a big difference. So even though you say that it is just a difference of one number, but that is very big in terms of approaching a particular number. So it has to be really small to the previous functional value to judge which number the functional values are getting closer. So as x tends to infinity, f of x will tend towards 4, correct? You can check in your with your table 4 for negative values, negative 10, negative 15, negative 100 and negative 1000. So let us do that. That would give us, if it is negative 10, negative 40 plus 1 would give us negative 39. Negative 39 divided by negative 12. So 3.25. f of x is 3.25. So I do not want to calculate 50. I'll go for 100 and 1000 so that I can directly judge the values. But if you are asked to do it like complete, it's a problem. So 100, that is negative 100 plus 1 would give us negative 99 divided by negative 100 minus 2. So that would be negative 102. So that is, so I'm doing something wrong. Okay, yeah, I'm sorry, I was like negative 400, right? So negative 400 plus 1 was negative 399 in the numerator, divided by negative 100 minus 2 would be negative 102, correct? So that would be 3.911. Okay, so 1000 for negative 1000. So negative 4000 plus 1 is negative 3999 divided by negative 1000 minus 2, that is negative 1002. So that would be 3.99. So it is approaching 4 again. So as x tends to negative infinity, f of x will tend to 4 again. So what is our horizontal asymptote? it is y is equal to 4. X is equal to 2 was the vertical asymptote and y is equal to 4 is the horizontal asymptote. I hope you got how to calculate asymptotes using table of values and analyzing the values approaching a certain particular point. So with this, I will end this video here, and we will learn about applying transformations to the simple function, that is 1 over x, to establish different rational functions in the next video, and much more too. Okay, so before I move on to the next video, I would like to give you the quiz. So do quiz 3.6.1. This is problem number 12. Problem number 12 in the book, that is page 308. Okay, so see you soon with the transformations. Thank you.